At the top level, Unix-like systems can be very convenient for common users, and they may not even know they are using this type of operating system. For example, currently the most commonly used operating systems are Linux-based Android systems and Unix-based Apple systems, in which the users only sees the user-friendly graphical user interface. But beginners who are just starting to learn Unix-like systems for administration and or development sometimes complain about their complexity. Don't be afraid. Actually, such systems are based on fairly simple concepts. There are only three things, 3.5 to be exact, you need to know to be comfortable with any Unix-like systems. Users, files, processes, and terminal lines. The first is not very well known to modern users, only because we now have a lot of computer devices with a personal access. Unix was created at the time when computers were an expensive rarity, and a single computer was used by many users. As a consequence, from the beginning, Unix had strong security policies and restrictions on permissions for users. And now on Unix systems we have dozens of users and groups, even if hidden by an auto-login machinery. And most of them are so-called pseudo-users, which are needed to start system services. As we will see later, they are required by architecture, since it is on the permissions of users and groups that the system is built to control access to system resources, process and files. If we are talking about ordinary users, they can log in with a username and password and interact with the applications installed on the system. Each user have full permissions only in their home directory and limited access rights to files and directories outside of it. This can be viewed as a foolproof. Common users cannot destroy anything on the system, just because they do not have such permissions. Moreover, they cannot view another user's home directory or protected systems, files and directories. To perform system administration tasks, the system has a special super user, generally called root, with extra permissions. At the system level, each user or group looks like an integer number, a user identifier and a group identifier. Files are the next important thing for Unix-like systems. Almost all system resources look like files, including devices and even processes on some systems. And the basic concept have been the same since the beginning of the Unix era. We have a hierarchical file system with a single root directory. All resources, including file systems existing on devices or external network resources, are attached to this file system in separate directories. This operation is called mount. On the other hand, you can access a device, real or virtual, as a stream of bytes and work with it like a regular file. All files and directories are owned by users, real or pseudo, and groups. And read, write, and execute access to them is controlled by permissions. Process is a program launched from an executable file. Each process belongs to a user and a group. The relationship between the owners of processes and resources determines the access rights according to the resource permissions. All processes live in a hierarchical systems based on parent-child relationship. There is an initial process on the system called init that is started at boot up. All system services are started from this initial process. There are fundamentally two types of processes in Linux: foreground and background. Foreground processes, also referred to as interactive processes, they are initialized and controlled through a terminal session. In other words, there has to be a user connected to the system to start such processes. They haven't started automatically as part of the system functions services. And background processes, also referred to as non-interactive automatic processes, are processes not connected to a terminal. They don't expect any user input. System services are always background processes. And finally, interactive foreground processes must be attached to the terminal session through the terminal line. At the time of creation of Unix, a TTY, teletype device, originally developed in the 19th century, was the primary communication channel between the user and the computer. It was a very simple interface that worked with a stream of bytes encoded according to the ASCII character set. The connection is made with a serial line interface, for example, RS-232, with a fixed set of connection speeds. This interface is still the main user interface for Unix-like systems. The implementation of each new form of user interaction, such as full-screen terminals, graphics systems, and network connections, all started with the implementation of simple teletype command line interface. Moreover, as we will see, this interface abstraction gives us a very powerful and flexible mechanism for communication between programs, possibly without human intervention.